Welcome to the Big Data Emerging Technologies panel. We have a great set of panelists here. I'm Milind Bhandarkar. I'm a chief scientist at a company called Pivotal. For those of you who do not know about Pivotal, Pivotal is a recent one-year-old spin-off from EMC and VMware. And we are focused on what we call as the third platform, which is sort of the intersection of cloud and big data technologies. Previously, I've been Hadoop midwife at Yahoo. I was there when Hadoop was born, and I might have helped deliver it a little bit. Since the last 3 years, I've been working in a company called Greenplum on MPP databases and Hadoop. And Greenplum was the one of the components that was spun out of EMC and is now part of Pivotal. So we have a great panel tonight. We have I think I've been now doing this panel, big data panel, for the last 3 years at GITPRO. I'm excited to say that this is the best panel, according to me at least, that we have got. Also, if you see the themes of the big data panels at GITPRO, that would sort of show you the how things have evolved in this big data ecosystem. The first panel that we had in 2012 was on essentially Hadoop distributions, and we had representatives from Cloudera, Hortonworks, and IBM on that. The second panel was big data applications and use cases, and we had a lot of very interesting panelists there as well. What we have seen over the last few years is that Hadoop has sort of taken over the world, right? You basically, there was no terminology called big data before Hadoop was even there, right? But and 5 years ago there was probably just one Hadoop distribution commercially available. Now there are something like 6. Last month it went to 5, right? So 5 Hadoop distributions today. And of course people haven't stopped at that. They haven't stopped innovating just because Hadoop has taken over the world. In fact, they have been growing Hadoop ecosystem and adding all the so-called faults of Hadoop. They are basically trying to address in that, right? So that's why the theme of this year is big data emerging technologies. So what I would like to do is basically introduce, I will ask everyone to introduce themselves, what they do, what their company does, and what they do in their company, and then we'll get started with the moderator questions, all right? So with that, I have arranged it alphabetically according to first name for some reason. So Ali.
Thank you. My background is I did a bunch of research at AmpLab at UC Berkeley on big data systems and cloud computing over the last 5 years. And some of the projects there included the Spark platform. So I'm now part-time at Databricks. I'm one of the co-founders. And Databricks is a company that we founded in July last year, 2013. And what it does is it's centered around the Spark platform. Essentially, the company has most of the people that have developed the core pieces of this platform. This includes Spark itself, but also on top of it, the SQL layer called Shark, the streaming framework on top of it called Spark Streaming, the machine learning library, MLlib, and there's also a graphical component now that lets you do graphical computations, GraphX. So this is what we're doing, and it's busy.
Right. Great. Amol?
Hi, I'm Amol Kekre. Been a veteran in the industry. The two areas that are relevant here is I led Yahoo Finance, Finance.com, it's the big site, and we have a massive streaming platform underneath. And the second role was to work in the Hadoop team at Yahoo. I've been very fortunate to have worked with fabulous engineers. A couple of them are on this table. So DataTorrent, I left Yahoo about 2 years ago, and the vision we had was to see how big data and real-time and massive computations come together, and whether we could deliver a platform that actually fulfills the promise of MapReduce about enterprise quality, about never going down, about being fully HL, linearly scalable, etc. And we have that out there. It's GAing now. And the way we see it is, it's one of the things that is a delivery of the promise of Yarn. We're fully Yarn native, and today I'll hope to discuss some of it with you.
Great, Arun.
Thanks, Milind. First of all, thanks to Milind and Conrad and everybody for having me. It's my first time here on the panel. So Hopefully Milind won't say the next time is better. Can you guys hear me? All right. So I've been working on Hadoop pretty much since day one, about 8 years now. I used to lead the MapReduce team over at Yahoo, responsible for fixing Hadoop if it breaks. So for a couple of years now, we sort of spun off and started a company we call Hortonworks, which is sort of one of the distributions Milind was talking about. In my sort of personal role, I lead large parts of engineering at Hortonworks. All right. And I've been working on MapReduce, I lead Yarn. Sanjay talked a little bit about it. And recently I've been leading some of the SQL efforts at Hortonworks too. So a lot of time working Hadoop. And again, thanks for having me.
Pankaj.
Hi, Pankaj Gupta. I'm a data scientist and in the search and content part of Twitter. And before my data scientist role, I led a team called Personalization and Recommender Systems. I co-wrote the follow recommendation system for Twitter called Who to Follow, open sourced a system called Cassaway. And so I'm more from the application side of the big data tools that we do. Previously, I founded a couple of startup companies and alumni of Stanford.
Stephanie.
Hi, I'm Stephanie McReynolds, and I currently run the marketing organization at a company called Trifacta. And Trifacta is a layer on top of the Hadoop distributions that assists with the data manipulation, data preparation process that data scientists and business analysts have to go through before they can actually turn that raw data in HDFS into actionable data, into data that's ready to visualize. Prior to Trifacta, I've spent about 7 years in the big data space. I was with a company called Aster Data that integrated SQL and MapReduce and competed with Greenplum, actually, so I'm sure we have many interesting stories we can share. And then prior to that, I've really spent my whole career in the data space, whether it was at Oracle working on complex event processing and business activity monitoring technologies, or prior to that, I was at PeopleSoft and Business Objects, more in the data warehousing and business intelligence spaces.
Great. So yesterday when I was thinking about how to introduce this panel, how to introduce the topic, I came across an event that is going on in Boston right now. Professor Mike Stonebraker, who has been involved in the database space since 1970s, I guess, one of the original developers on Postgres, and actually, as a professor in Berkeley, he actually took Postgres to commercial space with a company called Ingress, and since then he has founded a bunch of companies. He is now 70 years old, and his legacy is being celebrated in Boston, in MIT. So one of the things that Mike Stonebraker said in the last, I think about 4 or 5 years ago, he wrote a blog post and in ACMQ wrote an article along with David Dewitt, another very senior database researcher from University of Wisconsin, currently in Microsoft. So the title of his post was actually pretty inflammatory for us in the MapReduce and in the Hadoop space. He basically says MapReduce is a major step backwards. Right? If you read that article carefully, he's basically talking about a particular implementation of MapReduce and how it suffers from a lot of deficiencies or performance deficiencies in particular, and lack of good programming interfaces, etc. That's what he claimed, right? Now, at that time, we were skeptical of his claims, but now, as we see 5 years later, we basically see that a lot of programming models as well as systems that have been developed in the Hadoop ecosystem basically try to move away from MapReduce. I mean, we have seen over the last few years, we have seen the whole SQL on Hadoop space really heating up, and then we have seen graph databases, and then we have seen a lot of in-memory databases being run on top of Hadoop, right? So in a way, I would like to pose this question to this panel, right? All the panelists. In a way, it looks like Mike Stonebraker was right? That MapReduce was really a major step backwards, and then people have tried to circumvent the deficiencies of MapReduce. So a lot of these emerging technologies that you would hear about today. Let us put that in that context. Is MapReduce really going away? Are these emerging technologies really going to take over what MapReduce was doing, etc.? So I have a few questions already prepared. I'm going to be asking them to, I have a primary panelist about each question in mind, so I will be asking them first, and then any other panelist can express their views on their answers based on that, right? Okay, so let me start with Ali. So why Spark and why this Berkeley data stack? I think it's called Badass, right? So why Spark and Badass? I mean, where does it fit in this whole Hadoop ecosystem?
So I actually have two hats on. I'm also at UC Berkeley, and I'm also at Databricks. But Databricks actually is focused on the Spark platform. And Badass is bigger. So Spark was a piece of that. And that's what the research lab is doing, and they're doing research things on many things. What we're doing, we're focusing on the Spark platform. And essentially Spark is a piece of the Hadoop ecosystem. It's sitting on top of Yarn. I mean, Arun can tell you he had this vision better than anyone else here, that Hadoop wanted to support many different compute engines. So Spark is one of those compute engines that can sit, for instance, on top of Yarn, and it works well with that. It leverages HDFS. A lot of people out there are using the Hadoop file system, and then getting the data out of that, and then using Spark to do computations on that. And finally, there is Hive. So there's this component on top of Spark called Shark, which lets you do SQL on Spark. That itself leverages a lot of the code base of Hive in the Hadoop system. So it leverages the HiveQL, the query language. It leverages the metastore where metadata about tables are stored. It also lets you do UDFs and SERDES and these things. So it actually fits in the ecosystem there. But however, we do believe that as a compute engine for the computations, it is the most powerful one out there right now, as a general processing engine for big data. And there are three advantages, essentially. The first one is its speed. It's faster than anything out there. And I can talk about why. It leverages memory and storage hierarchies, things like that. It's much easier to use, so the abstractions have been simplified. So you can write very small programs rather than much bigger ones in most other frameworks. And the final one, which we think we're most excited about, is that it's a general platform that generalizes what many other frameworks on top of it would have to do in a specialized fashion. And this is where we actually go against Stonebreaker. He said that you can't have one size fits all, basically. But we basically show that you can do SQL, you can do streaming, you can do graph computations, and you can do machine learning on top of one framework like this. And this is where Stonebreaker was saying, no, you need one specialized one for each. That was his articles. So, yeah.
Anyone else want to comment on that?
Well, I guess I have to, right? I've worked in MapReduce now for 8 years. I mean, to be honest, if you talk to anybody in the MapReduce community, none of us actually believe that, you need one hammer, right? I mean, in some ways, the world is full of, simplifications and generalizations. Everybody wants to look at black and white, but reality is there's, lots of grays and other colors around, right? MapReduce was absolutely not the right programming paradigm to actually go build a SQL database. What MapReduce the reason why MapReduce sort of became popular, in my opinion, was a couple of things. It actually was the first freely available open source big data platform, which allowed you to process not just gigabytes and tens of gigabytes. It allowed you to process terabytes and petabytes. Milind was there at Yahoo in 2008 when we first went to production with Hadoop. We actually, MapReduce and Hadoop was targeted for the web search case, right? The web search is, in my opinion, sort of the quintessential big data application, right? To give you a sense of context, the first production app we wrote on MapReduce was this thing called WebMap. What WebMap was trying to do was actually create a graph of the entire web, right? So it would take every single web page in the world, and at that point we had, 100 billion in our index, right? So it took 100 billion web pages. It modeled them as a node in the graph, right? So you create a graph with 100 billion nodes, and then every single URL from yahoo.com or google.com became a link to some other website, right? So you have a graph with 100 billion URLs and probably a couple of trillion edges in that graph. So MapReduce and Hadoop sort of came from that background, right? It was trying to process data at massive scale and it had nothing to do with SQL or other things, right? Having said that, the reason MapReduce sort of became popular, in my opinion, was that it made it really easy for programmers to think and scale, right, without having to worry about fault tolerance and scheduling and many other things, which if you look at it, eventually, if you build an app at that scale, probably 80–90% of your code is going to be going to be dealing with failure handling, right? So what MapReduce allowed you to do was actually focus on just your business app. Obviously, it wasn't the best hammer around, but it was a really big hammer, right? And people really needed that hammer. And once we had that, an ecosystem started springing on top, which is Pig and Hive and so on and so on. And having said that, what something like Apache Hive has proven is that it's still the best platform for you to go do SQL at petabyte scale. If you looked at the blog post which came out from Facebook last week, they say that right now the data warehouse running on Apache Hive is up to 300 petabytes. Right? If you stop and think about it, that's massive. Right? 300 petabytes in a single warehouse is amazing. Right? So that's kind of the history MapReduce came from, and we can talk about why we want to go further, why we want to go away from just one hammer.
One thing one question that I had, a follow-on question, is that I think the whole Hadoop and MapReduce actually benefited a lot in terms of rapid development because it was written in Java rather than C or C++ or some low-level languages, right? One question that I have for Ali as a follow-on is that Spark Stack is written in Scala. Now, it's difficult enough to find good core Java programmers. Where are you going to find Scala programmers in, let's say, Kansas City?
That's a good question. So, I mean, first of all, it seems that, we don't have a huge problem actually finding these developers, it seems. I mean, there's over now 170 contributors, individual contributors just last year. And if you just look on the machine learning library, which is a small library that we just started, maybe 6 months ago or so, it's 33 developers already, contributed code to this. So it's, it's taking on, it's massively popular and people are doing it. In terms of Scala, uses the JVM. So you can interact with it with Java. And for Spark 1.0, which is coming out very soon, maybe in a couple of weeks, we're actually giving now Java 8 support. And Java 8 support with closures and all of these things that have been added, it's actually not, it's very close to Scala. So, you can imagine a lot of development happening on the Java side from now on. I mean, I prefer that personally over Scala. That's just my personal preference. So yeah, it's not a huge problem.
Yeah, that's great news. That's
also, Twitter has raised a generation of Scala developers, almost. We do a lot of Scala, and now we are a medium-sized organization with a lot of engineers, and we've always been a Scala house.
I should just mention one more statistic also. We did these polls on people that are using Spark, and we were all shocked ourselves. Python is by far bigger. The Python users, because so you can use Python, there's PySpark. It has more users than the Java version.
I see.
So that's a big one.
All right, so let's move on. Let me ask a question to Amol. So the way I see DataTorrent is it basically offers a streaming or complex event processing platform on top of it. All right, so for years we have been hearing about Storm. And with the recent announcements that Storm, from Yahoo and others, that Storm can now run on Yarn. So how does DataTorrent differ from, let's say, what Storm does?
Thanks for asking. So when we started DataTorrent 2 years ago, in fact, thought process was a little bit earlier, we asked a different question. So clearly, Storm streams have a lot of respect for Storm engineering, open source, smart people. We didn't ask a question, what would it take for data to stream? We asked a question, what would it take for you to write code and go home? Okay, you write A plus B, you go home. You write MapReduce, you go home. There's outage happens, nothing, nobody gets paged. As Arun just said, actually he worked in Yahoo Finance. It takes 10 seconds to write A plus B. It takes years to make it fault tolerant. The money and you're counting money, you're doing something that enterprise lives depend on it, it better not go down. What we are seeing and what we envisaged was coming together of big data and desire to have data analytics, results, feedback to front end, whatever, in real time. And when you have enterprises betting their lives on it, You want it to be fault tolerant, like the old tandem way. We don't lose the memory footprint, we don't lose the messages, we don't lose the state. Hadoop goes down, comes back up, we can come back up as if nothing ever happened. You want it to be linearly scalable, which means it works for 5,000 events per second, it goes to 1 million, it goes to 10 million, it goes to 1 billion. You don't change your code, you change your knobs, right? It has to be secure, it has to be all of that. We are a big data platform that happens to do stuff in streaming. But inherently, we have the religion of MapReduce. And our pitch and our sell is that if you bet on us, it will not go down. And when you start with that presumption, the architecture, the things you do are totally different. We did Yahoo Finance. We had 3 or 4 versions of it. In fact, Arun wrote one of that. We learned it the hard way. We learned it when the server goes down, someone gets paged, you come back up, you restart something, the site is storing stale data, you're losing customers. We don't believe it's, first of all, the expertise to do fault tolerant is pretty niche, it's pretty hard to do, it takes time to mature. And what you don't want is your engineers whose expertise is business logic of your IP, of your company, to actually worry about all those things. And MapReduce does that. MapReduce has that concept. And we have followed that religion. And the platform we have, I would say, happens to stream, but in reality, it's a big data, massively real-time computational platform that gives you the same value add that MapReduce gave without a paradigm limitation. So, and I have a lot of respect for Storm, but we are different. We're not the same thing. We are apples and oranges.
So let me ask a question to Arun as a follow-on in that case, is that the Hortonworks data platform, I think 2.1, has actually announced a support for Storm on Yarn as well, right?
Absolutely.
And I believe you are partnering with DataTorrent as well. Right? So how do you go to customers and try to distinguish between these two offerings?
Well, I actually haven't, shipped, I haven't, sold against DataTorrent, so I wouldn't share my secrets anyway. But the bottom line is simple, right? I mean, you go to an enterprise, we sit here in the valley, right? And I think you asked a great question, Milind, about how do you find programmers in Kansas City, right? The people who pay our bills are actually the people in Kansas City, or and so on, right? So enterprise is a different space, and sitting in the valley, we kind of get excited about technology and so on. What we do as Hortonworks is we ship what we feel is the best-in-class open source set of projects in the open source platform, because we are an open source company, right? Having said that, we don't expect everybody to throw away their existing infrastructure, existing proprietary or whatever solutions, because end of the day, most people, again, I'll go back to Kansas City, right? What they want to do is actually build, get some insight from their data, write an application, write some code, and like Amol said, they want to go home to their kids and have dinner. And then they don't want to turn up on Saturday morning and look at their pagers, right? So the bottom line is, the answer really is it depends. And like I said, it's not black and white. It's several shades of gray. And there are use cases where technology X is better, technology Y is better. I mean, you look at, databases are a great example, right? I mean, people have been writing databases now for 40 years. Is there one database to rule them all? No, right? There is Oracle, there is Teradata, there is SAP HANA, there is IBM Blue, and it's got, IBM DB2, and it's got 18 flavors of it. Maybe I missed 30 others, right? The answer is it actually just depends. Depends on the use case, it depends on the criticality of the application, it depends on what you're going to pay for it.
Great. So let me, okay, go ahead.
Actually, I agree with Arun a lot. We're on the same page.
Obviously.
In fact, I have a habit of calling him at wrong time and say, hey, Arun, it actually depends on your criticality. If you just want to have streams running, do some bean counting, have fun, Storm works. If HA is critical to you, if not counting money wrongly is critical to you, we have the features to do that. And we believe there's a lot of, in the ecosystem, there's a lot of area where those things are critical. We understand the open source religion of Hortonworks. We respected that. We were in talks with them a lot. We just happened to decide to go a different way. If we were open source, things would have been different. That's life, but there's place for Storm where you just count stuff, have fun, get paid, have fun. And there's a place where you count money or where your life depends on it and you can use us. I think both of them will exist. and both of them have a play in the ecosystem.
Great.
I feel like I should spice up the panel more.
I was going to say that, why are we not asking the guys about Storm, right?
Provide a counterpoint for Storm. So with Storm, we do count money as well at Twitter. That doesn't take away from the comments that are being made here. One sign of maturity of any technology or platform is that there are many use cases of it which emerge beyond the initial use case that is planned, and with that emerge many different solutions for it, and that's good overall for the health of the community, for the health of the industry. So I myself don't know too much